Circles on the plane. Well, good morning, good afternoon, or good evening, everybody. This is Mr. P signing in. Today we're going to be doing our guided notes for section 10.7, circles in the coordinate plane. All right, so the standard equation of a circle, where if x comma y is any point on a circle with the center of h comma k and radius r, that is, the center is at the point h comma k, and the radius of the circle in question is some number r, like that, then the equation is always going to be x minus h all squared plus y minus k all squared equals r squared. And that comes from the Pythagorean theorem, because there's your x coordinate, there's your y coordinate, and it's going to have a distance. That's the square root of the square of r. So basically, whenever you're looking at one of these, looking at in a circle and trying to find its equation, you check what its center is. So this circle is centered at 0, 0. So that's my h comma k. Then you have to check the radius. So the radius here, 1, 2, 3, 4. So the radius is 4. And so if the equation is supposed to be x minus h all squared plus y minus k all squared, and that's equal to r squared, you can actually just replace them with 0, 0, and 4. So that means that this is going to be x minus 0 all squared plus y minus 0 all squared equals 4 squared. And we do want to simplify that. 4 squared is 16. Y minus 0 is y, and y squared is y squared. X minus 0 is x, and x squared is x squared. So the equation for this circle is x squared plus y squared equals 16. And that's all there is to it. Take a look at this guy. Let's find the center first. Now, these circles, they're not going to give you usually too awful of a radius. So what you're going to look for a nice point here and check where is the center here. If you cross the vertical and the horizontal there, where is that center? So there it is. Which means that in this case, h comma k is equal to, looks like 2 comma 2. That's where the center is. And the radius is 1, 2, 3, 4. 4 again. Which means my equation is going to be x minus h, which is 2 squared, plus y minus 2 squared equals 4 squared. And I know what you're thinking. Should I square those out, like x squared minus 4x plus 4 plus y squared minus 4y plus 4, and do all that simplification? And the answer is absolutely not. I want you to leave the equation like this: x minus 2 squared plus y minus 2 squared equals 16. That is the standard form of the equation of a circle, and so I am not worried about expanding that and simplifying it any further than that. That's good enough for me. It should all be something squared plus something squared equals something. That's what your final results should look like. Now, circle with centers 0, 0 and a radius of a third. Again, this time it's actually telling you what h comma k is. H comma k is 0, 0, and the radius is a third, which means this is going to be x minus 0 squared plus y minus 0 squared equals the radius 1/3 all squared, which x minus 0 is x, x squared is x squared, plus y minus 0 is y squared is y squared, equals 1/3 squared, and 1/3 times 1/3 is 1/9. That's the equation you're looking for. Not too shabby. Now it looks like they've put the center at a negative, and that's okay, because there's my h, there's my k, there's my r. So we're going to do x minus my h, negative 3, all squared, plus y minus k, which is negative 5, all squared, equals the radius 8 squared. Now, when you subtract a negative, that's the same thing as addition, so this becomes x plus 3 all squared, plus y plus 5 all squared, equals 8 squared, which in this case is 64. Bam. That's exactly how I'd leave it. Okay, so the center of this is 0, 0, and a point on the circle is 4, negative 3. So there's my h and my k, but what is my r? Well, think of it like this. If you had a coordinate plane, I'm going to draw a really quick one over yonder. That's not what I wanted. There you go. Let's see here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 4 comma negative 3. So the center is here at 0, 0, and 4 comma negative 3 is over here, which means that distance is the radius. That's the radius of the circle that we're talking about here. So it's going to be like this. Let's see if I can get that drawn for you. There you go. Now, I am not so sure that that has a nice radius. Maybe it has a radius of 5, but I'm not sure because I only made that really quick sketch of it. So to be certain what the radius is here, we've got to find the distance between 0, 0 and 4 comma negative 3. So that would be a right triangle. Imagine a right triangle if you would. It goes 4 this way, 3 this way, and the distance, the r right here. So r, 4, 3. So 4 squared plus 3 squared equals r squared. And 4 squared is 16. 3 squared is 9 equals r squared. I sense good things. 25 equals r squared. Take the square root of both sides. Hey, presto, you get r equals plus or minus 5. Since the radius is a distance, it needs to be positive, so it's going to be r equals 5. So my radius is 5. And perhaps you already see, if h and k are 0, you can simply start off with x squared plus y squared, and that is equal to 5 squared, because 5 was the radius that we found, so it really did go through 5. And that means that x squared plus y squared equals 25. Hooray! Let's go the other way. Find the center and radius of the circle, then graph the circle. So x squared plus y squared. Well, before I put the coordinate plane down here, I better find out what the square root of this is, because this should be x squared plus y squared equals r squared. And I don't know the square root of 225 off the top of my head, though I do have the sneaking suspicion that it is 15. And so it is. Equals 15. Now that means that this has, it's centered at 0, 0. So we can actually go ahead and I'm going to make those like so, straight in the middle, because the center is at 0, 0. So I'm going to put a dot here. Now that center is not actually on the graph of the circle. You can see that that's true because 0, 0 doesn't actually satisfy this equation. 0 squared plus 0 squared is 0 and not 225. So this has a radius of 15, so we got to somehow get this out with weighted 15. 1, 2, 3, 4, 5. So if each of these counts as 3, we can get a radius of 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2, 3, 4. And the same up here. Each of these needs to count as 3. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Which means that my circle is centered at 0, 0 and has a radius of 15, comes out to that 15. Now, I understand you guys don't have the same tools I do, so if you actually do your circles like this on your paper, it's super not going to hurt my feelings, you guys, if you're just like, ugh. You know, all things considered, that's not terrible of mine. So you're just fine, guys. Do whatever you got to do. I'm going to use the tool so it looks nice and neat. And I don't know if this is just me having weird habits. I always erase the center because I don't want there to be any confusion that the center is not actually part of your graph. Okay. Okay, so this time it's not centered at 0, 0 because it's x minus h squared plus y minus k squared equals 16, which is r squared, which is 4 squared. I hope you don't mind. So x minus 3 tells me to go left 3. Y plus 2 tells me to go down 2. Yes, because x minus 3 tells me to go right 3 because x minus a positive 3 tells me to go right 3 from the origin. X minus a negative 2 tells me to go down 2. So I'm actually going to put this over here because it's right and down. So again, that minus 3 is telling me to take my center from 0, 0, where it normally lives, and go right 1, 2, 3. That was x minus a positive 3. Y plus 2 is y minus a negative 2, which means that's going to go down 1, 2. And there's my actual center. Oh, I actually missed 2. And then we can take the square root of 16, which is 4, and that tells me the radius. So from here, I would go up 1, 2, 3, 4, put a dot, left 1, 2, 3, 4, put a dot, down 1, 2, 3, 4, put a dot, and then right 1, 2, 3, oh donuts, 4, you get the idea, and then you can make your circle. Again, you don't have the same drawing tools I do, so it's not going to hurt my feelings if your circles aren't absolutely perfect, okay? That's what that's trying to say. Now see, this last one is exactly why I don't want to have to do this. I don't want to have this all expanded and simplified because how on earth are we supposed to graph this thing? Well, the truth is we need to take everything with an x and put it together. So x squared plus 2x, and then that's going to leave plus y squared plus 2y. I'm going to leave a little space here, equals 2. Okay, so the reason we have it grouped like this is because we want to complete the square on each part of this. So remember, to complete the square, you take the b, which is 2 over 2, always 2, and then we're going to square that, which is 2 over 2, which is 1, squared, which is 1, plus 1. Now I can't just add 1 to that, so I could either subtract 1, or I could add 1 to the other side here, and that's actually going to be what I want you to do. Same story over here. The b term is 2, divide it by 2 and square it. That's going to be what I want this third term to be, which is actually still 1 squared, which is still 1 plus 1. Now, why did I do that? Because these are now factorable. Because what multiplies up to 1 and adds up to 2? Well, 1 does. So this becomes x plus 1 squared plus what multiplies to 1 and adds up to 2? Y plus 1 squared equals 4. Oh yeah, I had to add an extra 1 up here because when I added 1 to this, I had to add 1 here to keep everything balanced. So that means that the center, and I'm going to go ahead and put this over here. Maybe I won't miss this time. The center has gone from 0, 0, where it normally lives, and it's gone left 1, down 1. Why left 1, down 1? Because x minus a negative 1 is plus 1, and y minus a negative 1 is plus 1. And the radius is 4, is the square root of 4, because you could replace 4 with 2 squared. So the radius is 1, 2 over here, 1, 2 up here, 2 down here, 2 down there, and there it is. That's the circle I wanted. So there might be a little bit of factoring and completing the square going on here. Please go back to the lesson on completing the square if you don't remember how to do that part, if that seemed odd and mysterious. Anyway, there it is, folks. Circles on the coordinate plane. I hope you learned a bunch. This is Mr. P signing off. Please let your instructor know if you have any questions, and I hope you have a wonderful rest of your day.